Hey guys, so here's the notes for 8.3 day 1. We are now going to show that a quadrilateral is a parallelogram. So in our last section of 8.2, we actually reversed it. We actually said, hey, this quadrilateral is a parallelogram. Here are the properties of all of the parallelograms. This case, we're going to reverse it. So we have the properties, and we're going to say, okay, using this property, is this a parallelogram? So we are now proving that a quadrilateral is a parallelogram. Now, while you are taking notes, I would highly suggest having your quadrilateral family tree chart out to help you out with these problems. Now, let's go through all the ways that we can prove that a quadrilateral is a parallelogram. One is our definition. Show both pairs of opposite sides are parallel. Now notice how they show this. They use arrows. So anytime you see arrows, that represents being parallel. Number 2, show both pairs of opposite sides are congruent. This is theorem 8.7. So notice that they show that both sides or opposite sides are congruent. They are the same measurement. Okay? Okay, let's look at number 3. Show both pairs of opposite angles are congruent. So this is theorem 8.8. So notice here that our opposite angles can be congruent. So they are the same measurement. Number 4, show one pair of opposite sides are congruent and parallel. So the single tick mark represents that they are congruent. And then don't forget, anytime you see an arrow on the sides when they're opposite, that means that they are parallel. And then our last one, which is theorem 8.10, show the diagonals bisect each other. Remember what that means, bisect. That means to cut into 2 equal parts, okay? So notice when we see the diagonals, on the same line, the 2 parts are congruent. They have the same measurements. There we go. Okay, let's use these ways to prove to do example number 1. Okay, identify our parallelograms. Explain how you know that the quadrilateral QRST is a parallelogram. Now let's look at A. Notice here that they have given us angles. So we will have to use what is presented on this picture to show that this is a parallelogram. Okay? Now, we have only 3 out of the 4 here. So we need to find what is that angle S. Now, remember from 8.1, right, that we can figure out what is the sum of the interior angles. And to do that, we use this formula. Okay, remember, N represents the number of sides. So we look here, we have 4 sides. So I have 4 minus 2 times 180. And then 4 minus 2 gives me 2. And then I do times 180, that gives me 360, okay? So now, from there, we're going to figure out that angle S. So to figure out angle S, we're going to add up all the other angles and then subtract it from 360, okay? So we have 360 minus 113 minus 113 minus 67. And you can use your calculator for this. So go ahead and plug that in. When you do, notice we get 67. Okay, let's put that where angle S is, because that's going to be very important. Okay, so a way to show this is a parallelogram is to look at our angles and know that, hey, if I look at angle S and angle Q, they have the same measurements. That means they are congruent. If I look at angle T and angle R, they also have these same measurements, so they are also congruent. And notice that Q and S are opposite angles, and T and R are opposite angles. So to show that this quadrilateral is a parallelogram, we know that both pairs of opposite angles, remember opposite means across, are congruent. Okay, let's look at B here. So let's figure out how can we show that this quadrilateral is a parallelogram. So notice what they present on the picture. They present to us diagonals. So that's what we have to kind of think about, the diagonals. Now notice, if we look at QP, that's 3x, and PS is also 3x. They have the same measurement, and so whenever something has the same measurement, we can say they are congruent. They are exactly the same. If we look at TP, which is 5x, that is also the same as PR, which is 5x, okay? So notice that the diagonals, that they are congruent and they're bisected. So what we can use here to show that this is a parallelogram is that diagonals bisect each other. So that means that they cut each other into 2 equal parts. Okay, make sure you watch the next part of this video, which we continue to prove that a quadrilateral is a parallelogram.